200 with reduced weight and increased range, similar to the 747 SP. However, the -100X would have carried fewer passengers than the -200 while having similar operating costs, leading to a higher cost per seat. By the late 1990s, design plans shifted to longer-range versions of existing models. In March 1997, the Boeing board approved the 777-200X/300X specifications, 298 passengers in 3 classes over 8,600 mi, 15,900 kilometers, 9,900 mi, for the 200X and 6,600 mi, 12,200 kilometers, 7,600 mi, with 355 passengers in a tri-class layout for the 300X, with design freeze planned in May 1998, 200X certification in August 2000, and introduction in September and in January 2001 for the 300X. The 4.5 feet, 1.37 m, wider wing was to be strengthened and the fuel capacity enlarged, and it was to be powered by simple derivatives with similar fans. GE was proposing a 102,000 lbf, 454 kN, GE 90-102B, while P&W offered its 98,000 lbf, 436 kN. PW 4098 and RR was proposing a 98,000 lbf, 437 kN, Trent 8100. Rolls-Royce was also studying a Trent 8102 over 100,000 lbf, 445 kN. Boeing was also studying a semi-levered, articulated main gear to help the takeoff rotation of the proposed -300X, with its higher 715,600 pound, 324,600 kilograms, MTO. By January 1999, its MTO grew to 750,700 pound, 340,500 kilograms, and thrust requirements increased to 110,000,114,000 lbf, 495/10 kN. A more powerful engine in the thrust class of 100,000 lbf, 440 kN, was required, leading to talks between Boeing and engine manufacturers. General Electric offered to develop the GE 90-115B engine, while Rolls-Royce proposed developing the Trent 8104 engine. In 1999, Boeing announced an agreement with General Electric, beating out rival proposals. Under the deal with General Electric, Boeing agreed to only offer GE 90 engines on new 777 versions. On the 29th of February 2000, Boeing launched its next-generation twinjet program, initially called 777X, and began issuing offers to airlines. Development was slowed by an industry downturn during the early 2000s. The first model to emerge from the program, the 777-300, was launched with an order for 10 aircraft from Air France, along with additional commitments. On the 24th of February 2003, the -300 made its first flight, and the FAA and EASA, European Aviation Safety Agency, successor to the JAA, certified the model on the 16th of March 2004. The first delivery to Air France took place on the 29th of April 2004. The -300, which combined the -300's added capacity with the -200's range, became the top-selling 777 variant in the late 2000s, benefiting as airlines replaced comparable four-engine models with twinjets for their lower operating costs. The second long-range model, the the 777-200LR, rolled out on the 15th of February, 2005, and completed its first flight on the 8th of March, 2005. The -200LR was certified by both the FAA and EASA on the 2nd of February, 2006, and the first delivery to Pakistan International Airlines occurred on the 26th of February, 2006. On the 10th of November, 2005, the first -200LR set a record for the longest non-stop flight of a passenger airliner by flying 11,664 nautical miles, 21,602 kilometers, 13,423 mi, eastward from Hong Kong to London. Lasting 22 hours and 42 minutes. The flight surpassed the -200LR's standard design range and was logged in the Guinness World Records. The production freighter model, the 777F, rolled out on the 23rd of May, 2008. The maiden flight of the 777F, which used the structural design and engine specifications of the -200LR along with fuel tanks derived from the -300R, occurred on the 14th of July, 2008. FAA and EASA type certification for the freighter was received on the 6th of February, 2009, and the first delivery to launch customer Air France took place on the 19th of February, 2009. By the late 2000s, the 777 was facing increased potential competition from Airbus planned A350XWB and internally from proposed 787 series, both airliners that offer fuel efficiency improvements. As a consequence, the 777-300 received engine and aerodynamics improvement packages for reduced drag and weight. In 2010, the variant further received a 5,000 pound, 2,300 kilograms, maximum zero fuel weight increase, equivalent to a higher payload of 20-25 passengers. Its GE90-115B1 engines received a 12.5% thrust enhancement for increased takeoff weights at higher altitude airports. Through these improvements, the 777 remains the largest twin-engine jetliner in the world. In 2011, the 787 Dreamliner entered service, the completed first stage aka the Yellowstone 2, Y2, of the replacement aircraft initiative called the Boeing Yellowstone Project, which would replace large variants of the 767. 300/300/400, but also small variants of the 777, 200/200/200LR. While the larger variants of the 777, 300/300, as well as the 747 could eventually be replaced by a new generation aircraft, the Yellowstone 3, Y3, which would draw upon technologies from the 787 Dreamliner, Y2. More changes were targeted for late 2012, including possible extension of the wingspan, along with other major changes, including a composite wing, a new generation engine, and different fuselage lengths. Emirates was reportedly working closely with Boeing on the project, in conjunction with being a potential launch customer for the new 777 generation. Among customers for the aircraft during this period, China Airlines ordered 10 777-300 aircraft to replace 747-400s on long-haul trans-Pacific routes, with the first of those aircraft entering service in 2015. Noting that the 777-300's per seat cost is about 20% lower than the 747's costs, varying due to fuel prices. Improvement packages, edit. In tandem with the development of the third-generation Boeing 777X, Boeing worked with General Electric to offer a 2% improvement in fuel efficiency to in-production 777-300 aircraft. General Electric improved the fan module and the high-pressure compressor Stage 1 blisk in the GE90-115 turbofan, as well as reduced clearances between the tips of the turbine blades and the shroud during cruise. These improvements, of which the latter is the most important and was derived from work to develop the 787, were stated by GE to lower fuel burn by 0.5%. Boeing's wing modifications were intended to deliver the remainder. Boeing stated that every 1% improvement in the 777-300's fuel burn translates into being able to fly the aircraft another 75 mi, 139 kilometers, 86 mi, on the same load of fuel, or add 10 passengers or 2,400 pound, 1,100 kilograms, of cargo to a load-limited flight. In March 2015, additional details of the improvement package were unveiled. The 777-300 was to shed 1,800 pound, 820 kilograms, by replacing the fuselage crown with tie rods and composite integration panels, similar to those used on the 787. The new flight control software would eliminate the need for the tail skid by keeping the tail off the runway surface regardless of the extent to which pilots command the elevators. Boeing was also redesigning the inboard flap fairings to reduce drag by reducing pressure on the underside of the wing. The outboard raked wingtip was to have a divergent trailing edge, described as a poor man's airfoil by Boeing. This was originally developed for the McDonnell Douglas MD-12 project. Another change involved elevator trim bias. These changes were to increase fuel efficiency and allow airlines to add 14 additional seats to the airplane, increasing per-seat fuel efficiency by 5%. Mindful of the long time required to bring the 777X to the market, Boeing continued to develop improvement packages which improve fuel efficiency, as well as lower prices for the existing product. In January 2015, United Airlines ordered 10 777-300s, normally selling for around $150 million per aircraft, were purchased for $130 million each, a discount to bridge the production gap to the 777X. In 2019, the list price for the -200 was $306.6 million, the -200LR, $346.9 million, the -300 $375.5 million and 777F, $352.3 million. The -200 is the only classic variant listed. Third generation, 777X-8/8F/9, edit. Main article, Boeing 777X. In November 2013, with orders and commitments totaling 259 aircraft from Lufthansa, Emirates, Qatar Airways, and Etihad Airways, Boeing formally launched the 777X program, the third generation of the 777, with two models, the 777-8 and 777-9. The 777-9 is a further stretched variant with a capacity of over 400 passengers and a range of over 8,200 mi, 15,200 kilometers, 9,400 mi, whereas the 777-8 is slated to seat approximately 350 passengers and have a range of over 9,300 mi, 17,200 kilometers, 10,700 mi. Both models are to be equipped with new generation GE9X engines and feature new composite wings with folding wingtips. The first member of the 777X family was projected to enter service in 2020 at the time of the program announcement. The rollout of the prototype 777X, a 777-9 model, occurred on the 13th of March 2019. The 777-9 first flew on the 25th of January 2020, with deliveries initially forecast for 2022 or 2023 and later delayed to 2025. Design, edit. Boeing introduced a number of advanced technologies with the 777 design, including fully digital fly-by-wire controls, fully software configurable avionics, Honeywell LCD glass cockpit flight displays, and the first use of a fiber optic avionics network on a commercial airliner. Boeing made use of work done on the cancelled Boeing 7J7 regional jet, which utilized similar versions of the chosen technologies. In 2003, Boeing began offering the option of cockpit electronic flight bag computer displays. In 2013, Boeing announced that the upgraded 777X models would incorporate airframe, systems, and interior technologies from the 787. Fly-by-wire, edit. In designing the 777 as its first fly-by-wire commercial aircraft, Boeing decided to retain conventional control yokes rather than change to side-stick controllers as used in many fly-by-wire fighter aircraft and in many Airbus airliners. Along with traditional yoke and rudder controls, the cockpit features a simplified layout that retains similarities to previous Boeing models. The fly-by-wire system also incorporates flight envelope protection, a system that guides pilot inputs within a computer-calculated framework of operating parameters, acting to prevent stalls, overspeeds, and excessively stressful maneuvers. This system can be overridden by the pilot if deemed necessary. The fly-by-wire system is supplemented by mechanical backup. Airframe and systems, edit. The airframe incorporates the use of composite materials, accounting for 9% of the original structural weight, while the third-generation models, the 777-8 and 777-9, feature more composite parts. Composite components include the cabin floor and rudder, with the 777 being the first Boeing airliner to use composite materials for both the horizontal and vertical stabilizers, empennage. The main fuselage cross-section is fully circular, and tapers rearward into a blade-shaped tail cone with a port-facing auxiliary power unit. The wings on the 777 feature a supercritical airfoil design that is swept back at 31.6 degrees and optimized for cruising at Mach 0.83, revised after flight tests up to Mach 0.84. The wings are designed with increased thickness and a longer span than previous airliners, resulting in greater payload and range, improved takeoff performance, and a higher cruising altitude. The wings also serve as fuel storage, with longer-range models able to carry up to 47,890 US gallons, 181,300 L, of fuel. This capacity allows the 777-200LR to operate ultra-long distance, transpolar routes such as Toronto to Hong Kong. In 2013, a new wing made of composite materials was introduced for the upgraded 777X, with a wider span and design features based on the 787S wings. Folding wingtips, 21 feet, 6.40 m, long, were offered when the 777 was first launched, to appeal to airlines who might use gates made to accommodate smaller aircraft, but no airline purchased this option. Folding wingtips re-emerged as a design feature at the announcement of the upgraded 777X in 2013. Smaller folding wingtips of 11 feet, 3.35 m, in length will allow 777X models to use the same airport gates and taxiways as earlier 777s. These smaller folding wingtips are less complex than those proposed for earlier 777s, and internally only affect the wiring needed for wingtip lights. The aircraft features the largest landing gear and the biggest tires ever used in a commercial jetliner. The six-wheel bogies are designed to spread the load of the aircraft over a wide area without requiring an additional centerline gear. This helps reduce weight and simplifies the aircraft's braking and hydraulic systems. Each tire of a 777-300 six-wheel main landing gear can carry a load of 59,490 pounds, 26,980 kilograms, which is heavier than other wide bodies such as the 747-400. The aircraft has triple redundant hydraulic systems with only one system required for landing. A ram air turbine, a small retractable device which can provide emergency power, is also fitted in the wing root fairing. Interior, edit. The original 777 interior, also known as the Boeing signature interior, features curved panels, larger overhead bins, and indirect lighting. Seating options range from 4 to 6 abreast in first class up to 10 abreast in economy. The 777's windows were the largest of any current commercial airliner until the 787, and measure 15 by 10 inches, 380 by 250 millimeters, for all models outside the 777-8 and -9. The cabin also features flexibility zones, which entails deliberate placement of water, electrical, pneumatic, and other connection points throughout the interior space, allowing airlines to move seats, galleys, and lavatories quickly and more easily when adjusting cabin arrangements. Several aircraft have also been fitted with VIP interiors for non-airline use. Boeing designed a hydraulically damped toilet seat cover hinge that closes slowly. In February 2003, Boeing introduced overhead crew rests as an option on the 777. Located above the main cabin and connected via staircases, the forward flight crew rest contains 2 seats and 2 bunks, while the aft cabin crew rest features multiple bunks. The signature interior has since been adapted for other Boeing wide-body and narrow-body aircraft, including 737ing, 747-400, 757-300, and newer 767 models, including all 767-400 models. The 747-8 and 767-400 have also adopted the larger, more rounded windows of the original 777. In July 2011, Flight International reported that Boeing was considering replacing the signature interior on the 777 with a new interior similar to that on the 787, as part of a move towards a common cabin experience across all Boeing platforms. With the launch of the 777X in 2013, Boeing confirmed that the aircraft would be receiving a new interior featuring 787 cabin elements and larger windows. Further details released in 2014 included resculpted cabin sidewalls for greater interior room, noise damping technology, and higher cabin humidity. Air France has a 777-300 subfleet with 472 seats each, more than any other international 777, to achieve a cost per available seat kilometer, CASK, around 5 cents. similar to Level's 314-seat Airbus A330-200, its benchmark for low-cost, long-haul. Competing on similar French overseas departments destinations, Air Caribes has 389 seats on the A350-900 and 429 on the -1000. French Bees is even more dense with its 411 seats A350-900, due to 10 abreast economy seating, reaching a 4 cents CASK according to Air France, and lower again with its 480 seats on the -1000. Engines, edit. The initial 777 models, consisting of the 777-200, 777-200A, 777-300, were launched with propulsion options from 3 manufacturers, GE Aviation, Pratt & Whitney, and Rolls-Royce, giving the airlines their choice of engines from competing firms. Each manufacturer agreed to develop an engine in the 77,298,000 lbf, 343436 kN, of thrust class for the world's largest twinjet, resulting in the General Electric GE90, Pratt & Whitney PW4000, or Rolls-Royce Trent 800 engines. The Trent 800 is the lightest of the 3 power plants as it weighs 13,400 pounds, 6.078 t, dry, while the GE90 is 17,400 pounds, 7.89 t, and the PW4000 is 16,260 pounds, 7.38 t. One initial 777 engine options. 2. Pratt & Whitney PW4000. 3. Rolls-Royce Trent 800. 4. General Electric GE90-94B with its thrust reverser deployed. 4 Boeing's second-generation 777 variants, 777-300A, 777-200LR, and 777F. Greater thrust was needed to meet the aircraft requirements, and GE was selected as the exclusive engine manufacturer. The higher thrust variants, GE90-110B1 and -115B, have a different architecture from that of the earlier GE90 versions. GE incorporated an advanced larger diameter fan made from composite materials which enhanced thrust at low flight speeds. However, GE also needed to increase core power to improve net thrust at high flight speeds. Consequently, GE elected to increase core capacity, which they achieved by removing one stage from the rear of the HP compressor and adding an additional stage to the LP compressor, which more than compensated for the reduction in HP compressor pressure ratio, resulting in a net increase in core mass flow. The higher thrust GE90 variants are the first production engines to feature swept rotor blades. The nacelle has a maximum diameter of 166 in, 4,200 mm. Each of the 22 fan blades on the GE90-115B have a length of 4 feet, 1.2 meters, and a mass of less than 50 pounds, 23 kilograms. General Electric GE90-115B. Variants, edit. Boeing uses 2 characteristics: fuselage length and range to define its 777 models. Passengers and cargo capacity varies by fuselage length. The 777-300 has a stretched fuselage compared to the base 777-200. 3 range categories were defined. The A market would cover domestic and regional operations. The B market would cover routes from Europe to the US West Coast, and the C market the longest trans-Pacific routes. The A market would be covered by a 4,200 mi, 7,800 kilometers, 4,800 mi, range, £516,000, 230-40, tow aircraft for 353 to 374 passengers powered by 71,000 lbf, 316 kN, engines, followed by a 6,600 mi, 12,200 km, 7,600 mi, B market range for 286 passengers in 3 class, with 82,000 lbf, 365 kN, unit thrust and 580,000 pound, 263 t, of MTO, an A340 competitor, basis of an A market 400.